This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello everybody and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber and today we're going to speak about Porsche and an AI project at Porsche. And I have two guests, Simon Dürr. Hello, Simon.
Hi, Robert.
And Professor Dr. Marco Huber. Hello, Marco.
Hello.
Before we start, please introduce yourself briefly to the listeners. Simon, please.
Yeah, thank you, Robert, for the nice introduction. Yeah, I already said my name is Simon and currently I'm working at a department of strategy and development in the customer order management process at Porsche here in Stuttgart. Yeah, maybe I try to first explain what we are doing at the department, or I go over to myself that the listener already know what a customer order management process does at Porsche. So the customer-to-customer process is an end-to-end process in the Porsche company, which is responsible for all the topics regarding planning and ordering. In terms of my person, I am responsible in that department for the strategic orientation of new technologies and new algorithms all around the topics planning and ordering. In addition, I'm currently doing my PhD in cooperation with the Fraunhofer IPA and the University in Stuttgart. And on my journey, Marco is supervising my thesis and is also working with his team in cooperation with Porsche on the redesign, prototyping, and on the implementation of new concepts.
Okay, perfect. Marco.
Okay, so thanks for having me. I have actually two hats I'm wearing. So at one side, I'm a professor.
Always two hats with Marco.
Yeah, it's always complicated with me. I'm with the University of Stuttgart, where I'm a professor for cognitive production system, which is actually AI in manufacturing. And on the other side, I'm leading two departments at Fraunhofer IPA in Stuttgart. One is concerned with machine vision and signal processing, where we do a lot of quality control. And the other one, and that is the one where we had this cooperation project with Porsche, is called Cyber Cognitive Intelligence, which is the AI department of Fraunhofer IPA. And one of our core topics is autonomous decision-making, where we, for instance, are concerned with planning processes and how they can be supported by machine learning technology and AI technology. And this is the reason why we had this project together with Simon and Porsche.
Simon, we already recorded an episode in German about the project. I think it's 1 year ago. Can you give us a short recap? What was your approach? And then we will discuss how this project went through.
Okay, of course. Yeah, as I already said, we started our cooperation with the Fraunhofer IPA and the University of Stuttgart in 2018 or 2019. And we started in 2018. We thought about our current systems and processes. And back then, I think we saw a lot of challenges and the uncertainties, but also the chance to use new technologies and new methods like AI or mathematical models. Which if we look back, maybe 20 years, we were not able to use these methods because of technology's limitations. And I think that was the start where we thought about doing some collaborations also with leading institute. And this brought us to the idea to go the new ways and focus not only on cooperation with familiar and already known partners like SAP or other technological partners, but also on the cooperation with these innovative institutes and leading universities, such as the cooperation with the team of Marco.
But what was your approach? What was the idea?
The idea was, I think it started with the announcement of SAP in 2019, where SAP has announced that the support for the R3 modules in planning and ordering has or will stop in 2027. So, and nearly all systems currently at Porsche regarding the planning and ordering run in several SAP modules and are often really highly customized due to the unique requirements of the Porsche process. And this announcement brought us to the point to overthink the current, let's say, monolithic approach of SAP and to redesign the whole process by thinking more in a service-orientated way. So now we try to do, let's say, a new strategic orientation of the entire planning and ordering process by following, and I do not want to say a greenfield approach, but a mix between a green and a brownfield approach to redesign the process.
How did you do that? What did you have to do for this? And where's the AI coming in?
Of course, maybe I will jump a little bit more back to give the listener also the background, because nearly I think it's now 24 years ago. The current planning and ordering process has been implemented by only a few persons in our department who had the idea to integrate an end-to-end process in the company from the first contact with a customer when ordering a vehicle until the delivery of the vehicle to the customer. And this includes all the steps in order management, such as scheduling orders, the production of orders, the procurement, as well as the distribution and delivery of the cars. But not only the ordering perspective is in our responsibility, but also the planning topics, which are really essential to guarantee that a customer can order a car that he or she want. And the planning process includes volume planning, capacity management, and so on, item planning. And as I already said, 24 years ago, are gone since the initial implementation. And I think the world has changed since then. We have a lot more products. We have a lot more configurations. Maybe just to give a short impression, we are leading sport car brand with more than 200 different product variants and billions of possibilities in terms of configuration. We started to think more, let's say, in a state-of-the-art way and to think in integrated and learning systems in human-machine interface and so on.
The goal was to optimize the planning for the production or the connection or the front end to the customer?
It's both. So on the one side, of course, it's the, let's say, internal logic, how we plan and order cars from a, let's say, company perspective, but also to provide a more intuitive and intelligent way to provide more transparency for a customer.
Marco, what was your first impression when you heard about this project?
I just remember quite well the situation. We were sitting at the cafeteria at Porsche, where the Porsche guys explained to me the current situation and what they would like to achieve. And I thought, that's a massive step. As Simon just said, the large number of variations, the increasing uncertainty in the supply chain. I think everybody has some impression how big this uncertainty can be. We have this unfortunate war in Ukraine, and a lot of cable manufacturers are sitting there, which has a significant impact on the supply chain. And all these kind of uncertainties need to be considered in a proper planning process. And it was obviously that this is a really challenging task. And we decided, and this was really remarkable, it became not just, let's say, a 3 months feasibility study. Just from the start, Porsche gave such a trust in us that we established a 3-year project, which was now extended by another year. So it was clear from the beginning, this is something we really have to work on a very significant time span to achieve what Porsche wanted to achieve, to incorporate the planning, the item planning, and all the things Simon just mentioned.
What was the main pain point, Marco?
The main pain point was really that Porsche was no longer, let's say, a company with a maybe focus on the German or European market. It's a globally acting organization, and the customer behavior in different markets is really different. So the so long established planning process was no longer fitting to the different behaviors of the customers in the different markets. So the challenge was really how to incorporate a new planning logic where it is possible to reflect these different market situations, and in the same time also to allow to incorporate all the different kind of variations and then uncertainties into the planning.
And Simon, what is your solution now, and which role AI plays in it?
My solution, or let's say the results, were really good. I think, to be honest, we are currently on a stage where we defined a lot of concepts, a lot of prototyping, where we work together with the colleagues of Marco, and we saw that the results we have experienced were really, really, really good. And let's say in terms of a couple of different perspectives. So on the one side, of course, it's really important for the customer who has a lot of flexibility over the whole ordering process, but also from a factory perspective to have a stable and production and logistics process. And I think AI and also some other mathematical methods help to, let's say, to reach this goal, to ensure the flexibility for a customer and also for ensuring the stability in the factories.
So you combine mathematics, statistics, and a modern machine learning approach, or is it a different approach?
No, it's completely correct. So it's depending on the module. So we have implemented a lot of modules over the whole process. I think some of the models are really based on AI technologies.
Can you give us an example?
Yeah, of course. So maybe I also want to give a little bit more background. What was, let's say, our task, or what was the challenge? And maybe I start to explain a planning paradigm. It's called the concept of blend orders. And we are really intensive using this concept blend orders by generating virtual blend orders. So, and that's exactly what the concept of blend orders does. So in the end, it's about to create virtual orders which are completely specified with all the options, with all the information. All the configurations are feasible in terms of a feasibility check regarding the product structure rules and some constraints. And once we have this, say, complete specific configurations, we start to build some planned order book scenarios. And the third step was, now we have this, let's say, virtual order blend book, and we try to assign the real incoming customer or stock orders to this virtual already planned or scheduled blend orders.
One question, are these artificial data sets then, or what is it?
Yeah. So as I already mentioned, it's depending on the steps. So in the first module, we use Bayesian networks. It's kind of artificial intelligence where we learned and built up some already said Bayesian networks to sample these configuration suggestions. And I think these Bayesian networks can handle and represent especially the complex product structure information as well as all constraints between the options in a really smart way. And I think that's really important. And it's not, let's say, only the difference between AI and mathematical optimization, because I think the biggest thing is that, let's say, that the method is really fast and can be used in a practical or in a real world application. And I think that's really important. And for example, regarding these Bayesian networks, we worked on that and we, let's say, did a separation between an offline algorithm to create and to do the whole inferencing of the network, but also to have an offline perspective to generate this vehicle configuration. And just to give you a number, we are able to generate configuration in less than 1 millisecond, which makes it really practical in real-world application.
Marco, can you explain to us how difficult is it to combine a machine learning approach and a classical statistic mathematic approach?
Of course, I can do so. Maybe we just stick to these Bayesian networks. For those who might be familiar with those, it is very common that Bayesian networks are handcrafted by a human expert. You have an understanding how a process works, and then you start to design the structure of the network. This is actually what we didn't do in this project. So it wouldn't be feasible because of the complexity of the entire manufacturing process and the configuration process. This would be an endless endeavor to do so. So we decided to create the Bayesian network structure automatically from data, and data sources we used here, for instance, are historical sales, or there's also a car configurator available, as probably any car brand has it nowadays, because this gives also some impression what might be new trends, that maybe orange is the new black when it comes to the color of the car. So this is also then reflected. And then we used a reinforcement learning algorithm actually to train these structures, these Bayesian network structures. So there's no human involvement here to create the structure. And once this is established, then it's quite easy to sample a significant amount of cars from this Bayesian network, and all these cars which are sampled are actually feasible to build. So there is no configuration in the car that would not be allowed to be produced later on, which is also a novelty compared to other approaches which go in a similar direction.
But you mentioned you used this historical data, but Simon mentioned there are also artificial data, or am I wrong?
Not really artificial data. You can consider a plant order as artificial data. I think this is how Simon meant it. So this plant order is not a customer order. It's a virtual item that we consider then later in later planning stages as it would be an actual customer order. That's how the virtuality comes in here. But the Bayesian network structure is really created from real world data, as I said, historical sales and, for instance, configurations from the car, internet car configurator. And of course, it's also reflecting all these constraints we do have during the manufacturing. So it's, for instance, not feasible to build certain options simultaneously in one car because they mutually exclude themselves. And this is also reflected in the creation of the structure.
Can you go once again a little bit more detailed in this reinforcement learning for this Bayesian network?
I think here it makes sense to hand over to Simon,
sure.
Because it's part of also his PhD thesis, so he can elaborate a bit more on that.
Simon, it's your turn.
Thank you, Marco. Yeah, as Marco already said, we are using reinforcement learning to, let's say, to optimize the structure of the Bayesian networks. So we learned that, of course, there are some constraints between the, let's say, options or option families regarding to the ordering of a car. And in the reality, there are not only the real constraints that option A maybe forces an option B, but there are also some correlations. For example, if a customer will order a really, let's say, high expensive rim, maybe he wants to order a high expensive sound system too. And these correlations are not really reflected in the constraints. So when I try to learn this Bayesian network without considering these correlations, then the results of sampling is not really good. So what we try to do is to use reinforcement learning by, let's say, creating some rewards between our real, let's say, order take rates, where take rate is the percentage of orders which are, let's say, configured with a specific option. That's the take rate of the option. And then we say calculate the reward between the real order take rates and the forecasted take rates. So then we have a good, let's say, measurement to define this reward function and to test which structure of the Bayesian network would be the best.
Can you explain us how you deployed this model then in your daily base or in your daily work?
Yeah, as I already said, of course, we are just on a conceptual or prototyping levels. We are currently not having this implementation in our daily life, or it's not live yet. But we are working on that. So I think it will be the next years when we try to focus on the implementation and on the operationalization of these prototypes and on these concepts to transform them in an operative way.
So do you need to improve the model, or what is the idea?
Yeah, I think the model works really good. But yeah, to be honest, we are just evaluating the model with a couple of markets, with a couple of models or product variants. Yeah, I'm really sure that it works also for all the other product variants or for all the other markets. But for sure, I think we have to test it when we are doing the implementation. So yeah, we will improve the algorithms, we will improve the reinforcement learning concept and so on. But I think we have a good starting point. We have a really good stage where we can jump in the future. And from this starting point, we will do the operationalization, yes.
So Porsche is a smaller or a more specialized manufacturer, car building company. Is there a limit to this approach, do you think?
Yeah, I think it's depending on the aggregation level. Of course, if we look at Costa Rica and we only order, let's say, 20 cars a year, yeah, it's really difficult to forecast the right blend orders. So yeah, it would be, let's say, misleading if we say that we can forecast 20 blend orders and exactly these 20 blend orders will be ordered by real customers. But on the other side, I think we have 90 or 95% of our cars sold in big countries, and especially in these big countries, we've also not only a customer market but also a stock market where it's on the one side really important to forecast the right car, but on the other side, it's also important that, for example, the sales area or the regional managers can sell the cars as we have, let's say, forecasted the cars.
Can you put the first result once again together? What are the main results you see?
Yeah, the main result is that we have prototyped a concept where we saw that the results were really good in terms of, let's say, to make the whole process more stable.
What does it mean, more stable?
Yeah, to illustrate the whole point is that, for example, we are working with it's called order book. So currently the order book can be seen as a two-dimensional system where on the one dimension there are the days and on the other dimension there are some constraints. And then order comes in and will be online scheduled in the day it fits. In the future, we will implement this blend order book. So we will have our first optimized try or draft to fill the order book with blend orders. So it looks from a perspective of an order book, it looks the same as if the order book would be filled with real orders to make a better forecast than if you do not have any orders in the order book. And I think that would be a really massive improvement, because if the real orders came in it's not you starting from a baseline, because the baseline is much more higher than today. So today the order book is empty and the first order came in and it's from 0 to 100. And in the future, it's maybe from 90 to 95 or to 85. If we talk about, let's say, the configuration precision.
In my opinion, it's a planning operator tool. Where's the man or the min in the loop? Where's the Porsche man or woman who controls the system?
So the control becomes significantly reduced. So currently there's a significant involvement of the human operator in the planning process, because once there's an issue, like that the customer order just does not fit in, then it's a duty of the human operator to start an optimization. And this role is significantly reduced because, as Simon already explained, you already, at every point in time, you have an optimized book. Order book. And of course, there's still the possibility for the human to modify things, but it becomes more obvious to the human operator what are the impacts when he is doing a change in the plant order book. So it should ease the job of the operator significantly, and he gets also, or she gets, much better transferability, or it becomes more transparent to the human operator about the planning status and all the procurement that is necessary to produce the cars.
Simon, how flexible is this AI model or this main model when you add a new car, when you add a new model, when you add a new, new sound system, new seats, whatever?
Yeah, it's depending. First of all, maybe I want to finish my introduction to the plant order, because in our understanding, it's divided into 3 parts. So the first part is the generation of these plant orders and what we do with Bayesian networks. Then we have the derivation of this plant order book scenarios, what we are doing with mathematical optimization, such linear or integer programming. And the third part is the assignment of real incoming customer and stock orders to these plant orders. And exactly there we have we call it like a recalibration or readjustment algorithm. Of course, it would be fine if we can forecast for the next year all the cars when the customer comes in, it's perfectly fit to our forecasted virtual orders. But of course, I think it's improbable that all of our virtual orders will match exactly to the customer wishes. And therefore, we have concepted the idea of this already mentioned recalibration algorithm to permanently optimize these virtual orders by taking into account the information of the incoming real orders.
Can you go a little bit deeper in this algorithm?
Yeah, of course. And what you were asking is, for example, if there are some changes in the product structure, maybe an option will be added to the product structure inside of a year. That's really a thing which, for example, reflects the Bayesian, the construction or the learning or the inferencing of the Bayesian network. But to be honest, it's not that often in relation to the importance. How often do we need to sample new configuration system based on an already learned Bayesian network? So that's what I initially mentioned. It's a difference between the offline learning, so the inferencing, the structural learning, and so on can all be based on an offline algorithm. So maybe it took 1 hour. Nevertheless, the real importance is the performance when we sample this configuration from this perspective. And what I said, we can sample really, really fast, and then makes it really practical in our real-world application.
What are the next steps, Marco?
Oh, there's plenty of next steps you can think about. So, for instance, currently the planning is done on a monthly or weekly basis. So what happens is that the cars, you know which cars should be produced, let's say on a calendar month or in a calendar week. But what is currently not reflected is on a daily basis, maybe on an hourly basis, really how the car is scheduled into production. This is a more fine-grained planning, and this is currently done directly in the plant. So the plant is deciding. So they get from our side, from the planning side, they get, let's say, the day. Say, this is the cars you need to produce, but then the plant manager is deciding which car and which order needs to be produced. Of course, if this is also considered into the planning, we can also optimize this simultaneously. And hopefully this further improves the stability of and the accuracy of the planning process. So this is one step that could be part of future work. But maybe, Simon, you have further insights.
Of course, yeah, for me, it's really interesting not only to look further in terms of, let's say, new methods or new chances to improve this concept, But also, as you already asked, Robert, it's also about the operationalization in our context. Because a few years ago, a smart man once said to me, the most important thing to create successful processes is the following: organization follows process. And I think it's really important, because I totally agree. Because if we do not align our organization on the new processes, we will fail. And I think now we have really good concepts. We have really good prototypes, which are here, are there, are in the sideboards of myself and my colleagues. And now we have to start to use these new methods and to create benefits, not only on the paper or on a concept view, but also on a practical view.
How difficult is that at Porsche?
Yeah, it's. I think it's not that easy. As I already said, 25 years ago, we had just, I think it was 2 or 3 guys who delivered the process, and now we are more than 100 persons who are working on this end-to-end process at Porsche. So it's a huge organization. It's a huge, let's say, silo we have in our process, especially also on the interfaces to the procurement, at the interface to the production. So I think that the processes are, say, as it is today. So it's good. They work, but I think we have to look further in the future. And now we had a chance to use the technologies such as, let's say, cloud services or intelligent methods such as artificial intelligence and so on, and to find or to define a target picture to handle also the uncertainties and to ensure, the factors such as flexibility, stability, or transparency over the entire planning and ordering process. And I think that's really important. And I think, what I already said, organization in that case have to follow the process.
The clock is ticking for you and the planning process, right?
Yes, of course.
Yeah, because you mentioned this deadline in, what was it, 27 or what?
2027, yeah.
Yeah, 4 more years.
Yes. Of course, that's our plan, to implement all these concepts regarding the modules I've already explained. In this year, we are working on some data structure, on building up, let's say, the input data on a qualitative high level to use them in the following processes, such as the Bayesian network. And I think we will start to do the implementation of these Bayesian networks and all the other stuff by next year. And hopefully we will be finished. And I'm sure we will be finished in 2027.
Marco, as a scientist, as a researcher, what was particularly exciting from your point of view on this project?
Oh, there were so many aspects.
So
one of the most was really the plant order, because the plant order, the quality of these plant orders decides the entire process. Actually, you can consider this as a glass bowl. So we are building a glass bowl, and the more clear it is, the better and easier becomes the subsequent step, like the planning and the recalibration and stuff like that. Ideally, we would find plant orders with 100% accuracy. Then there is no need for a recalibration afterwards. But of course, this will never happen. And really, one of the challenges and then scientifically most interesting part was the creation of these plant orders based on the Bayesian network structure, because we really had to find a solution where the human involvement is as limited as possible. As I said already some minutes ago, usually Bayesian networks are created with a significant involvement of humans. And this was just not an option. So we had to find a solution for this structure learning thingy. And this also needs to be super fast, and it needs to be many kind of different data sources, which was also way beyond you can find in scientific papers, where you maybe just have one data source to create something, but we have several data sources like the historic orders, the configuration, and all these constraints. All these things had to be reflected into this algorithm for creating the Bayesian network. And this was scientifically maybe the major step in this entire project.
Simon, last question. Is there any interest in other brands as well for this approach?
Yeah, of course. I think it's, especially looking at my PhD, it's more general perspective what we have looked at. It's not only something Porsche can use, it's only something which can be used by all companies or all manufacturers which, let's say, has multivariant products or production. So, for example, in the aircraft industry, it's nearly the same, because if you look at the planes, they are also highly customized when do the individualization of such a plane. But also in other industries, it's really interesting to use these technologies. And I had a discussion together with Marco a couple of days ago, and when we talked about Fissmann, who is also working with plant orders. And I think this concept with blend orders, it's really, really interesting, let's say for the future, because when we go a couple of years ago, it was technological, from my point of view, not possible to generate these blend orders in an efficient way that it can be used. Because Porsche was also thinking about blend orders years ago. But now I think we have the chance to use these technologies and to use these ideas and to, let's say, to better forecast also in planning, but also in ordering when we're looking at these recalibration algorithms.
Concerning Fissmann, but you have to wait for the new contact person now to promote your approach.
Maybe it's something for Marco.
Yeah. Marco?
Yes. I think that's actually a good point. So I do have an established contact with them, but I have not called them since the news are out. Hopefully, this is still valid, this connection.
This colleague is not available.
He hopefully is. He just wrote me some days ago, but it was before the news. So I have to see.
So is it possible to use this approach for different industrial sectors, right?
Yes, definitely. As Simon said, this plant order concept is nothing we invented. From an academic perspective, this is out since more than a decade, so to say, but it was really difficult to find an algorithm, a solution to really use it effectively. And this is what we did. This is one of our major contributions. And based on that, it is applicable to all industries where you have this high flexible production. So where you have products which can be customized or where the number of variants is really huge. Of course, if you do have just one product without variation, then it's not a concept you should apply here. That makes no sense at all. Therefore, you can find more easy planning solutions. But as soon as the number of configurations is in the order of several thousands or millions, then this concept makes really sense. And this you can find in many industries.
Thank you very much, Marcos. Thank you very much, Simon. It was a pleasure to talk to you. Thank you for this great project. And I'm very happy that we also have an AI project in the industry sector without large language model. Thank you very much.
Thank you as well. It was a pleasure.
You're welcome. For me too. Bye-bye.